Hi everybody. Okay, so now we're on to lesson 1.2. This is going to, well, this is still really the beginning. This is a cluster of chapter ones, if that makes sense. So anyway, this micro subchapter. In this lesson, okay, we're going to be looking at some different types of sampling, okay? First, we're going to go piggyback on what happened last lesson, and we're going to talk about what a sample is, okay? And then we're going to get into sampling frames, errors in representing sampling frames, and, sampling definitions and things like that. Okay, so first of all, why samples? All right. Remember in the last lecture we were kind of looking at like samples versus taking a consensus, right? So if we're comparing the two, we want to take a sample of the population because we want to do inferential statistics. Okay, we want to be able to infer what is actually happening with that population. Okay, what is going on in that situation, regardless of whether the topic is or whatever the frame or the scope of your study is. We want to be able to take a sample so that we can study that and infer what is actually happening with that population. Okay. If we were to compare that to doing a consensus, okay, you would find that taking a consensus to figure out what exactly is happening with the population, getting information from everyone in that population, it would be expensive and very time consuming, okay? And what you would figure out in the end is that really you would have pretty much got the same answer anyway, because taking a really good sample, being able to sample well if you do it right, you're pretty much going to get the same answer, okay, if you compare it to taking the census versus getting a good sample. It's just way easier. You're going to get the same result either way, and which is why I'm saying taking a census and all that stuff, that is just impractical, it's expensive, it's unnecessary, which is why we want samples. Okay, so now let's look at sampling frame. So a sampling frame is a list of individuals from which a sample is actually selected. All right, so pretty much the difference between a sampling frame and a population is that the sampling frame is going to be more specific. Okay, so it's the objects or the specific individuals that you want to use. And then your population is going to be more generic. Okay, anyway, so the list of individuals can be a physical concrete list, okay, that you came up with. For example, it could be an actual list of students that are enrolled at a nursing college if that's who you wanted to survey. Okay, or it can also be a theoretical list. And what they mean by theoretical list is that the list hasn't actually been formed yet. So an example of that could be if you wanted to survey patients that are going to go into the emergency department that day, but they obviously haven't showed up yet because it hasn't happened yet. So it's a theoretical list. It's like a list for the future, kind of like that. Okay. Okay, so undercoverage. What is undercoverage? So undercoverage is when you have your population and your sample frame and certain members of that population are omitted. They're taken out. Okay, that's what it is. Now, how does that even happen? Well, sometimes that just happens. If you're not careful, that can easily happen. So let me give you a scenario. as to how that can actually happen. So if we're kind of going back to how the previous example with the emergency department, with those who present to the emergency department, okay, if we're looking at nurses, right? Nurses who work in the emergency department. Well, if we're just going off of a list of nursing students might not include everyone for administrative reasons. Okay, or not necessarily nursing students, but the nurses that work in the emergency department. Okay, so it might not include everyone. Reasons for that could be some of the nurses might just be per diem or temp nurses, so they're working with the agency and they're not actually on the payroll in the ER department. Or you know, the shift nurses during the daytime are probably going to be different from the ones at night. So you're not really going to get a full 24 hours unless you're very focused on making sure that you include those people. You kind of have to know or figure out the ways in which people can get omitted from your sampling frame and find ways to prevent that to happen. Okay. Okay, so back to lesson 1.2. Now we're on this slide, errors in statistics. So this is not necessarily going to be drawn from the previous slide. This part of the lecture, I'm just giving you more terms and more things to be aware of. Okay, so first we have fact of life error. This is not necessarily an actual coined term. Okay, this is just something that I want to say because I think it describes this type of error a lot better than the actual term, which is sampling error. Okay, so in the books you're going to see sampling error, but I think if you call it fact of life error, it just makes a little bit more sense. The reason being because this type of error, this is like that natural expected error that is just, it's already expected just because it's expected that you're going to have some sampling error just because you're taking a sample of a population and you're not, you know, interviewing everyone and you're not taking census. Okay, so just because they're taking a sample and we're going to infer on that sample, we should expect there to be a small percentage of error. Okay, so so this is really the difference between the actual population average or mean and the sample mean. Okay, and this is expected. This is just normal. All right, what isn't normal is this part right here. Oh, God, why does it always say non-sampling? I don't know why autocorrect likes to change this. Okay, so this is non-sampling error. Okay, so a non-sampling error is what you want to watch out for. Okay, this is something we can actually help. Okay, and though how do you get non-sampling error? It's through having a bad list. So you just have a bad list of information. An example of this could be, let's say you were trying to take you're doing a study. You wanted to survey maybe everyone that works at a certain school, all the faculty members. And maybe one of your colleagues was like, oh, I could totally help with that. And they give you like an Excel sheet of all the information on all the faculty that they think is in the school. Okay, and then later on you find out that all that information for all the faculty members, some of the people on that list aren't even faculty, maybe they quit, they don't work there anymore. And then some of the people that you were actually, or some of the people who are actually faculty at that place might not even be on the list. Okay, so you're not getting, not everyone that you're trying to get is represented in your sampling frame in that situation. And when that happens, you got a bad list, and that is non-sampling error. Okay, so this slide piggybacks off of the previous one, causes of error. All right, so fact of life error or sampling error, we already kind of discussed this a little bit. So it's caused by the fact that regardless of whatever you do, okay? Whatever you do in your study, you will not 100% perfectly get it right because you're using a sample, okay? So there's always a little bit of room for some sort of discrepancy. All right, it'll probably come really close. You can, if you do play everything right, set it all up correctly. We also have to factor in the fact, just the fact that there will be a little bit of error because you're taking a sample and it's not like a complete exact census of survey of, everyone in your study. Okay. However, the non-sampling error, all right, this is because you did some things wrong, all right? These are things you want to avoid and which you can avoid, all right? So this is just caused by poor sampling design, sloppy data collection, inaccurate measurements, instruments, bias in data collection. We all have biases. We have to challenge our biases when we do studies like this because, could get some non-sampling error in there. Other problems that could be introduced by the researcher, all the researchers are human beings, so we're gonna have biases. We're not gonna be perfect. We might not even know what we're doing, all right? So we might not even know that, realize what we're doing, that we are introducing sampling error into our study, but it could actually happen. But yeah, so these are things that you need to actually watch out for. You have to actively, when you are doing research, you have to actively try to stay away from non-sampling error, okay? Bad. This one is good, or this is okay. You can't help that, but it's minimal, all right? That's the not good one, and we can help that to the best of our abilities. So a simulation is defined as a numerical facsimile or representation of a real-world phenomenon. So basically, this is like you creating a pretend situation that acts like a real situation so you can study that. That way you understand the real world situation. It makes sense, and when we move forward, it's going to make a lot more sense, and this is actually what a lot of researchers do, okay? So, in conclusion, well, not really in conclusion, but in sampling, okay, we want to make sure we stay away from non-sampling error, so the sampling that we can actually help. All right, so stay away from sloppy lists and bad lists and any kind of sampling error that we might be exposing ourselves to, because we're already going to have just the natural sampling error. All right. Okay, so now we're going to start going through different methods of sampling. Okay, so we're going to first look at simple random sampling. We're going to go through two different methods of simple random sampling. Okay, and then but first we're going to look at what is simple random sampling, and then further on we're going to go through some limitations that simple random sampling actually has. So first, the definition of simple random sampling is a simple random sample of N measurements is a subset of the population selected in such a manner that every sample size N from the population has an equal chance of being selected. Did you guys get what that means? Okay, let me tell you. All right, so so basically what this means is, like, let's say you have a certain sample size, okay? You have a certain population that you want to take measurements for, or want to take whatever you're doing, you want to take readings from a certain population, okay? And let's say you want to take, you have a list of the population of students in your class, all right? and you want to take a sample of 5. So N is 5. That's the amount of, that is going to be the amount of objects or individuals within the population that you want to take your sample from, that you want to take all the readings from. So if you take a simple random sample or an SRS from the class list, that means that all the different possible groups of 5, okay, since you're taking 5 individuals from the population, all the different possible ways, you know, of all the different students in that class have an equal chance of being in that 5, okay, a completely equal chance of being picked in that 5. And it also means that, like, if you, let's say you picked a random sample of 5 students, right? If you wanted to redo this experiment again, all those students have the exact same chance of being picked in another batch of 5. Okay, so completely equal and random is simple random sampling. Now, provided, okay, that that no undercoverage is happening, that you're staying away from any kind of non-sampling error, all right, everyone has an equal chance of, you know, being selected in the sample size. Okay? Hello, everybody. I think you guys probably noticed that I'm in a completely different setting than I was a while back, or since the last slide. And then before that, I was somewhere else as well. So, I mean, I've just been moving around a lot. I just, for some reason, can't sit in one place to make this lecture video happen. Anyway, so just for fun, what I want to do is say whoever can come up with a funny, crazy story about why I'm in all these different settings, different clothes, different, you know, a different place in the last couple slides throughout this lecture, you're going to get extra credit. So the craziest story in the comment section, okay, the craziest, funniest, made-up story in the comment section is going to win a big amount of extra credit, okay? So please write some stories. It'll be so much fun to read them, and I am definitely going to give you extra credit. If you have a username on YouTube that is not your name, then you can email me, so that you can email me to let me know who you actually are. Okay? Anyway, let's move forward with our lesson. Okay, so all right, so when we were last talking, we were talking about simple random sampling, right? Here there are 2 methods to simple random sampling. Let's look at one method. This is probably the easiest method, and we've all done this. We all did this in elementary school sometimes when there was like a drawing or, you know, anything like that. It's the whole pick a number or a name out of the hat situation. So what you do in this method is you're going to number all the individuals in your population with a unique number. Okay, so you probably want to give them for example, you could use their ID numbers, or you can just assign them numbers. It could be a student ID, it could be driver's license, whatever. Just give them a unique number, okay? And then you're going to put all of the numbers in that population who are participating, just fold them up, put them all together in that hat, right? And then mix it up, and then draw out 5 papers with different numbers, right? And those 5 numbers will be the 5 individuals who get to participate in the study. So that's your 5 individual sample, okay? So that's pretty much all it is. It's just, and the significant thing about this that you guys have to know is that when we put them all into that hat and we drew them out, each individual or a number within that hat had a completely equal chance of being, selected. They all, every single one in there had the exact, equal chance of being selected, and we just chose a random one or a random 5. Okay, so that's what's important there. Okay, so then the next method that we can use for simple random sampling will be to, this is where you generate your own list. Okay, so you generate your own list for random numbers for the population. Okay, so you come up with your own numbers. I would keep the numbers small, but you come up with your own unique numbers. Okay, and you hand them out randomly to or you assign them randomly to the individuals in the population. Okay, and then this is where you can also use a hat or something like that. So then what you're going to do is you pull numbers from a hat, and you can just say the first 1 through 5 or first 1 through 10, whatever sample size you're going for, and then you'll be like, okay, whoever got number 1, whichever one of you random people have number 1, then they get to participate in the study. And then you can grab your second number, and whatever number that is, whoever you assign to be that number can participate in the study. So really it's very similar. This is pretty much the same thing, and you're going to achieve the exact same result. It's just kind of like a little bit of a different way to do it. Okay. Okay, so the whole point of simple random sampling, the whole objective is that everything has an equal chance of being selected, or every individual in the population has an equal chance of being selected as to be part of the sample for the study, right? So, I mean, in the first method, we use like the old-fashioned hat, okay? You can literally put numbers into a hat and just choose one, okay? Or choose however many you need for your sample, and everything in there has the exact same chance of being selected, right? And then the second method, we can actually do an electronic version of that method as well. I forgot to mention that on the last slide. So what you could do, like let's say maybe you wanted to sample like local hospitals in San Bernardino County or something. Maybe that was, so maybe those are the individuals in your population. What if somebody put all of the hospitals together in an Excel sheet, and so you're just trying to figure out exactly which ones you can randomly select for your study, and maybe you only want to select 5. So what you can do is you can assign each hospital in that Excel sheet a random number, okay, just any old random number, and then you can put all those numbers in order, and maybe the top 5 are the ones that you choose for your study. And that way, you're not going to be biased and only choosing like the hospitals that your friends work at, or, whatever. So, second method, electronic hat. It can be used electronically, okay? But in both ways, you have an equal chance of like any of those individuals within that population that can be selected. Okay, so that's the whole point of that. So remember we said we were going to talk about the limits of simple random sampling. Okay, so here they are. All right, so first of all, in order to do random sampling, you have to have a good list. A good list is everything. You can't get a decent sample size. It's just not going to work because you won't have the right people in your sample that will represent everyone in that population. Okay, if you're leaving people out, then it's not going to represent the population that you're trying to study. So having a good list is like everything. That's first step, everything. All right. So yeah, I mean, sometimes you have a good list, it's great, it's being provided for you, you went out there and you searched for it, and you got a good list of everyone that you need to, randomly select for your sample. Great. But many times you can't get, it's not actually going to be easy for you to get a good list of everything. Like, for example, if you want to actually look and see who's going to be, if you want to do a list of, or a study of like people going to the ER department, okay, like patients, you don't know which patients are going to end up at the ER department in the morning, throughout the day at all. So you would not be able to generate a decently good list prior to going through that whole day, okay? Because you don't know who's going to show up. You don't know which patients are going to show up. ER is very dynamic and unpredictable, okay? So that's not the type of list where you can just go, hey, can you give me a list of the patients? Not until after everything has already played out. But anyway, also, having a good list, if you don't have a good list, you risk having undercoverage and having non-sampling error in your thing, all right? Like, for example, one time I needed to gather information of faculty, okay? And the thing is, the list I was given was just the list of the faculty that were listed on the website. Okay, so, and that has not been updated in, I guess, clearly a while, and I wasn't aware of that. The person who gave that to me did not think about that. So when I was actually working with that information, I didn't know that a good portion of the people on the list, the faculty on the list, did not even work for that university anymore. Okay, and then there were so many new faculty members that were not included. So I was doing a lot of work for nothing, and then I wasn't including other people that needed to be included. So if I were to use that as a sample size, if I were to take a random sample of just that list for a study, that would be bad because it's not a good representation of everyone who actually works there. You're including people who don't work at there, and you're also excluding certain new faculty members that do work there. So that would be a terrible list, all right? So limits of simple random sampling. Okay, so next we're gonna look at stratified sampling. Okay, so this is gonna be a little bit different from simple random sampling because this isn't going to be very random. I mean, you can apply some SRS into this, and I'll show you where and how, but stratified sampling is going to be a little bit different. And I think the biggest part about stratified sampling, or when you want to use stratified sampling, is when you want to know what a minority thinks, all right? When you want to know what's going on with the minority. The thing is, let me explain from the very beginning. The reason why I put this rock-looking Grand Canyon thingy photo here, the reason why I put that there is just to show you what this word even comes from, just so we can kind of get an understanding of what stratified is. So stratified comes, or the root word of that is strata, right? And strata or stratum, they're like these little striations, right? These different layers. So I think a good word or a good synonym for this, so it could just be layers, all right? Or levels, different levels, all right? When you have different levels of stuff, maybe in a population, among all the individuals in that population, you might have certain, different levels, different classes, or different, different something going on there, right? Different categories. Now, the majority of the population could actually fall into just one big category, and then you might have just a couple people or individuals falling into the other minority categories. The thing is, if you were to use simple random sampling on the situation where you wanted to know what everyone thinks, when you have maybe one majority, is like this, right? You just have so many individuals of that majority, and then when you have just, a bunch of like different minorities. If you did simple random sampling where everyone here had an equal chance of being selected randomly in simple random selection, do you think you're going to get everyone actually has equal representation in that study? And, if there are a bunch of minorities and like a huge majority, if you kind of give every single one an equal chance of being selected for the study, you're more likely to select more people from the majority than you would of the minorities. I mean, you could even end up with a sample size of everyone end up being part of the majority and not even getting any of, the minorities in there. So if you're doing a study where you care about you care about all the different parts, all the, different categories within that population, if that's what you're looking at, then you definitely need to go stratified. All right. So, how do we do stratified sampling then? All right, so what you're going to do, the first step is to divide the entire population into distinct subgroups called strata. The strata are the different levels or the different categories, okay? So these strata are going to be based on specific characteristics, or, the categories, they have to be based on specific characteristics. Like maybe if you're looking at income levels, okay, or if you're looking at ages, okay, age groups. You could be looking at different religions or anything like that, whatever you're trying to study. Okay, so you have those specific categories that you're looking at, right? And you should be able to divide the entire population. Be like, okay, so we have this many of the people who fit into high income, and then this many people fit into middle income, and then these people fit into low income. Okay, you should be able to group them and, divide the population into those categories. All right, and then all members of the stratum, okay, the stratum are the individual categories, okay, should share this specific characteristics. So everyone that you're studying within this population, they should all be able to share that specific characteristic, okay, and each one who's in each individual stratum, okay, they all have to share unique characteristics. So if you're doing income levels and you're just doing 3 income levels, it could be like all the people who have low income have to be part of a certain range. If they're not, then they are booted out. They can't be part of that category. And maybe they'll fit into another category like middle. So middle income can only be a certain, range of income. And only if you fit into that range are you able to sit in that particular category. Okay, so then once you've been able to split up all the individuals in the population based on those stratum or the categories, the individual categories, then within those individual categories or within the stratum, the individual categories, okay, then you can actually do simple random sampling, but just within those, those stratums, okay, those categories. You can do simple random sampling, find your sample size for each of the little minorities or the stratums, okay? And then you'll be able to actually figure out, you'll have a good representation of each group, okay, when you actually look and you start, plotting the answers, on a graph, okay, you'll be able to see what's going on within each group, okay? So each group has representation within your study, okay? Okay, so here are some examples of stratified sampling, and then let's look at some of the limitations of stratified sampling. So some examples could be, let's say you wanted to get a good study with high school students, and you wanted to make sure that they were all you're getting a good representation of each of the different grades, right? Freshman, sophomore, junior, senior. You want to make sure you have enough of them in there. And you're probably thinking, you know what, normally there are way more freshmen than seniors usually, because at a certain point, I mean, some high schools, at a certain point, people start dropping out and things like that. It might not be normal over here. It might be somewhat unheard of, or not as heard of as it used to be back in the day, especially. But, I think in some schools there is more of a higher dropout rate. But anyway, so if you're a school that has kind of a higher dropout rate or something, you know that your senior class is going to be way smaller than your freshman class, right? And let's say, and if you want to make sure that you hear from everyone, you get a good sample of all the different grades, you probably want to stick with stratified sampling over simple random sampling. Okay, another example could be, let's say you want to, in hospitals, you want to sample certain ICUs, okay? The ICU departments in a variety of different hospitals in San Bernardino County, okay? And you want to look at like the patients specifically, or you want to look at the providers in from these departments. In some hospitals you might have more providers. Some hospitals might have less providers. You can't necessarily take your simple random sampling is if you want to make sure that you get the hospitals, okay, like the hospital departments, you want to make sure that each individual hospital department has good representation, then you want to make sure that you go with stratified sampling instead of just simple random sampling, because if you do simple random sampling, you might not be able to zoom in and see what's going on with each individual hospital. It's probably going to be more of like a generic thing, because in certain hospitals and their ICU departments, they might have less staff. Okay, it might be a smaller area that they serve, so they might have less patients. Okay, and then other hospitals might be bigger, serve a larger population, so they're going to have more people to sample from over there, and then more than likely, those hospitals, the bigger hospitals, are the ones who are going to be part of the study, and it's going to sort of push the smaller hospitals out. So if you want to get good representation of all the hospitals, then you're going to want to go stratified. Okay, so anyways, now let's look at some limitations. So limitations of stratified sampling. Now, a big one, probably the main one, would be oversampling. Okay, and this is the obvious one, I think. So you just have to be mindful of the fact that that when you do stratified sampling, you're basically like amplifying the power of the smaller groups, and you're kind of making the large group less powerful, because you're equaling the playing field here when you do stratified sampling, because you're taking each individual category or stratum, and then you're doing simple random sampling and zooming in on that. Okay, so when you do stratified sampling, it's usually not a good representation of the whole population, okay, given that there is a majority of people here who fit into one category, and then there are other minorities, so it's probably not a great representation of the entire population. But when you know that when you want to do stratified sampling, you're not trying to get the entire, you're not trying to be general. You really want to focus in on certain groups. Okay, you want to make sure you hear from everyone that exists in the population, not just the majority. And that's just something you have to know if you choose stratified sampling. Now, if you're doing a higher level statistics, then you can actually, there are ways which we are not going to go over in this class, but there are other ways if you actually move forward and do a lot of research and work in statistics a lot, where you can actually kind of simulate, there are different algorithms that can be used where you can simulate and make it so that it is more of an actual representation of what's going on with your population. Okay, even though you are zooming in on what's going on with the minorities there, you can kind of be able to plot it out so that it actually shows you what's really happening with the entire population. Obviously, we're not doing that here. But anyway, so some more limitations of stratified sampling. It is not possible to do this without a list beforehand. You have to have a list. It can't be like SRS where you can technically, even though it may not be advised, but you can kind of sample as you go a little bit. That would be sloppy, but it's possible to do. It's not even possible to do that with stratified sampling. You have to have your population and your individuals all ready to go. You have to have your list ready to go before you start trying to organize and get your stratified sampling method started. Next, it is also difficult to do. It's more time consuming because you have to choose your strata. Okay, you're going to choose your different stratum or the categories that you want to look at. Okay, and then you have to take the individuals in your list and you have to divide them amongst the stratum. Okay, so you have to put each individual from the list into what category they fit in. Okay, so it's more time consuming. And then you can start working on the sampling part. Okay, so there's a bit more work into that. Okay, so now let's look at systematic sampling. Hey, so now we're really getting somewhere. All right, systematic sampling. It's like a system, okay? So systematic sampling can actually be done without a list or with a list, either or, okay? And basically, okay, so here's the basic idea of like how the systematic sampling method works. Okay, so you range all of your individuals in the population in whatever particular order, and then you just pick any random individual to start. Okay, it doesn't really matter. Even if you were to pick your friend, there's no way you can, make this really bias the whole thing. And let me show you why. All right, so these are your individuals, right? Pretend. Okay, so let's say you picked this one. You just felt like it. It felt right at the time. That's your first one. Now, every other individual after that, you're gonna choose any kind of random, number or any number in your mind, right? And that is gonna be your K or your kth. All right. So every kth, number, that is going to be a chosen one for your sample size. All right, so kth or kth, that is going to basically mean every so many. All right, so if you said your K is going to be your every so many number is going to be 3. That was a weird 3. So let's say you said every 3. So that means every 3 individuals, that's going to be your individual that's chosen to be part of your sample size. So if you started at this one, this was your starting point, and then you went every 3, you would go 1, 2, 3. Oh, here is your next individual that is going to be selected for your thing. Then from here, you're going to pick your next person in your sample. 1, 2, 3. Oh, here's another person or another individual that's going to be part of your sample size. Okay. You could have did it every other one, every 4th, every 5th, every 2nd. We chose every 3rd for this example, but you know, as you go throughout the list, every 3rd, if you choose every 3rd, then it's still pretty, you're spreading out your sample and you're choosing random ones throughout the whole thing. So even though it's not necessarily perfectly simple random sampling, this is still a good, it's a good solid way you can get a good sample size, okay? Because you're really spreading the whole thing out and choosing amongst all the individuals. And you're not necessarily picking only your friends. You might start with an individual that for whatever reason, maybe you just chose it. You try to stay unbiased, but for whatever reason, that was your first one. But the thing is, you're not calculating and making sure that you get the other ones in order. Okay, you just choose any random number, and then that every kth individual is going to be part of your sample. So I hope that makes sense to you guys, how the system works. Now you can do this with or without a list. So without a list could be, like, it could actually be if you wanted to sample the individuals, the entire population that will go into the emergency department as a patient, you know, in one day. And you wanted to just start as use like the very first patient as like your starting point, and then you tell yourself, okay, after every like 4th patient, I'll take any 4th patient that shows up, every 4th patient after that. And so that will give you a pretty good sample size, and that will be pretty evenly dispersed, well, somewhat, because you're also going to be thinking about, well, there might be more patients that come in the morning than in the afternoon. So if that is a factor, then of course systematic sampling would not be for you. If it matters what part of the day, okay, then maybe systematic sampling is not necessarily the right sampling method. Okay, but if the different part of the day does not matter, then using this type of a method would actually work really well if you were just looking at the patients that show up in the ER department throughout the day. Like that would, you know, this would be a good sampling method. Okay, so examples of systematic sampling from a list. Okay, let's say you're given a list, all right, and we're going to look at the classes that are offered during a semester, okay? So you have your list of classes that are offered that semester, and let's say you choose any random, your initial one has to be any random number, okay? Choose any one. So off the top of your head, maybe you choose 3. Okay, so that means you're going to go straight to the 3rd class, and that is going to be your initial sample individual, right? Then choose any other random number. So maybe you pick 5. Okay, so that means every 5th class on the list after that 3rd one. Okay, so you already picked the 3rd one, but then every 5th class on the list, okay, is going to be an individual in your sample size. All right. So now let's look at some limitations of systematic sampling. So if you are doing a list or a population, okay, where maybe you have a pattern of data, okay, your list is a pattern. It might go boy, girl, boy, girl, boy, girl. Okay, for that type of a thing, where boy-girl matters in your study, you do not want to do systematic sampling. Because the thing is, systematic sampling, essentially the methods that we're using to take samples, individuals, we're basically using like a pattern. So if the sample list, or if the list that the population list that you're going through is in a pattern and you're using a pattern on top of that, you might accidentally leave people out of it might not be very random, because you might be leaving certain individuals out, certain specific individuals that are important to be represented in your sample. But since you're using a pattern on top of the pattern, like for example, what if your pattern was boy, girl, boy, girl, boy, girl? Let's just use that example. And the random number that you chose to pick, okay, through using systematic sampling was, let's say, 2. Or what if you chose 4 or something like that, right? So it would be, okay, let me show you something. Let's say these are the boys, right? And then these can be the girls. Well, if this is your initial individual, this girl right here, okay, and you said every 4th individual is gonna be chosen for your sample, what's gonna happen? Let's see, 1, 2, 3, 4. All right, so this individual's chosen. Then you go 1, 2, 3, 4. This individual's chosen. Okay, and then through your population, are you getting a good representation of everyone on the list? Are you? No, you are not. If you look, basically only girls have been chosen so far. Now, what if we were saying, oh, okay, well, how about we want to do like let's do an odd number. Let's make it 3. Okay, 3 can be our random number that our kth. Okay, so starting from this individual, because this was our initial one, right? This girl right here. So let's do 3 every 3rd. We go 1, 2, 3. So this individual is going to be chosen. Then we go 1, 2, 3. This individual is chosen. And then 1, 2, 3. Then the next individual will be chosen. So looks like we can, in some ways, you can actually get you could possibly get like an even disbursement or good representation using systematic sampling if you did have a pattern, but it's really advised not to do this with a pattern, because you have to actually figure out which numbers you can or cannot use in order to get a good a good sample size, okay, good sample representation. All right, because this isn't always going to work out as clean as it was here. All right, if you were using more complex patterns and whatnot, you wouldn't be able to get a good amount of representation regardless of what number that you choose, you know. So if you do have a pattern going on, you can't just choose any random number. You have to actually think about what number you can choose that would work with this. And I mean, that wouldn't be random. That's not really a good sample, because you're being deliberate as to who can, who's going to be included in your sample size, and it kind of throws the whole thing off. All right, so you should not ever use systematic sampling on like a pattern type of data. Okay, so also you can do systematic sampling in a clinical setting where you do not know who is going to come in that day. So like I was trying to give the example earlier about, like, let's say, what if you wanted to sample all the patients that come into like an ER department? You don't know who's going to come in that day, but you can use this method if you wanted to really sample the patients, okay? Get a good sample size of the patients that came into the ER department that day. Do you kind of see how we can spread it out like that? So it works. Okay, so now we're going to look at cluster sampling. Why are we looking at cluster sampling? Gosh, this sucks. There's so many different types of sampling, and there's still more to go. You still have other different ways you can pick out your sample size, your sample group, before you even do your study, before you even collect your data. Isn't that crazy? So cluster sampling, this is when you're only going to use this, and it's very important to use this, but like you really only want to use this for a specific thing. You want to do this when you have like an issue, there's a problem happening in a certain geographic location. Okay, so if there's a specific area, let's say San Bernardino County, okay, pretend this is a map of San Bernardino County, okay, and you got like, I don't know, because I don't know where everything is, I don't know, pretend this is like the high desert, and then here's like Palm Springs and stuff like that, and then, well, I think they're kind of connected a little bit, I don't know, and then I think there's like mountains behind, and like San Bernardino and Riverside and Moreno Valley and all those places, dude, I don't know. Oh yeah, Riverside's not even part of this. Take it out. Anyway, okay, you know what? I should clean that up. Okay, pretend these are just different areas of San Bernardino County. Okay. All right, so, well, if there's an actual problem happening in San Bernardino County, like maybe there's COVID. Okay, pretend there's COVID happening, and that's the problem that we want to focus on just in San Bernardino County. Pretend that's the only area in the world where it's happening, so we want to zoom in on that specific area to figure out what is going on. Okay, so since we say, oh, it's all happening in San Bernardino County, that's where the problem is. Well, we're going to look at a map of San Bernardino County, okay? And then we're going to start dividing the map into all the different geographical areas. So we put different geographical areas within the county. All right, that's what all this is. Different geographical areas. Maybe there's a specific area there. Then what we're going to do is we're going to pick random clusters, okay, from the map, from this divided geographical area. So we could pick a random cluster here, and we'll take this random cluster, and maybe we'll take that random cluster. These are random clusters, okay? And then within these clusters, we're just going to take all the people in the cluster, all the individuals, all right? And we're going to, those are going to be your sample size, so you're going to get your data from them, okay? Okay, so problems with cluster sampling. Why might you not definitely want to use it when it's not going to work for you? So when you're doing cluster sampling, sometimes, because see, we're looking at different people who live in specific geographic locations. And the thing is, sometimes when people live in certain locations, they live there because, I mean, they cluster in those areas because it's part of like their culture, or it's maybe it's like a certain class of people who gather in that area, or maybe maybe there's just, I mean, people tend to live in areas where there are other people that are just very similar to them, okay? Like you might find certain areas of San Bernardino County where there are just more low-income people than any other socioeconomic group of people, okay? There might be certain areas where there are more people of a certain religion, in that area, because maybe there's like a huge church or, temple or something like that where they all gather. So, like in some ways, sometimes it's really hard to use cluster sampling because there may be other variables, other factors acting on, that certain population that you're, or certain factors acting on the population that you're trying to like scope out and study and find like maybe the cause of a certain problem. Okay, and there could be other factors that are associated with that and maybe causing that problem as well, or it could, what could be, the thing is, cluster sampling isn't always going to be able to weed out the problems and, make it more obvious about what's happening. Okay, in a situation where it seems like everyone is doing the same thing, everyone is has a similar lifestyle, and whatnot, then cluster sampling might not help. Okay, for example, let's say you're looking at cancer rates, okay, and you realize that in a certain town in this country or a certain like county in this country, there are just really high cancer rates. And so you're trying to do cluster sampling to see what is actually going on in the population that might be causing cancer. Now the problem is, in that certain town, there could be like a mine where people, a lot of the people in the town work there. Maybe there's a lot of pollution in the area. Maybe that's just like that particular geographic areas where a lot of low-income people live. So so quality of life isn't that great to begin with. So there could be a lot of factors associated with high cancer rates in that specific area, and cluster sampling may not actually weed out the actual problem. Okay, so I hope that makes sense. Okay, so now we are down to the last two. Yay! We're almost done with checking out all these different ways to sample. Now, let's go through convenient sampling right now because it just feels so nice hearing that word, because it's convenient. Yeah, it's so convenient. Okay, so, and that's just what it is. It's just a really nice, convenient way to sample. Think about it. Well, let me explain why it's nice and convenient. Okay, so convenient sampling can be used under any kind of low-risk circumstance. Okay, if you don't have to be very specific about your sampling, if you're not really looking at any specific well, anyway, if you don't have to be as specific and like strict with yourself about what data you are allowing in, okay, if you're not having to filter through and put up hard filters, then convenient sampling can really work. Okay, is it always going to be the best representation of the population? Maybe not. But there are ways in which it's a great way to get your sampling done. So anyway, a really good way to do convenient sampling. Here's a good example of like, what if you wanted to know, what if you were like a kid in 4th grade and you wanted to do your science experiment on which ice cream tastes best? Okay, at that, maybe there's like an ice cream truck nearby, and you're at the park or somewhere where like everybody's gathered in line to get this ice cream, and you want to find out exactly which ice cream is the best. So really all you need to do is just do convenient sampling. Just stand in front of the truck, and every time someone gets in line to order their ice cream, ask them what they think is the best ice cream, and then that you can collect your data like that. And your sample size will just be everyone that shows up and buys ice cream. Okay, and for that reason, it's very convenient. It's just whoever shows up. Okay, so if you're in a situation where this is convenient for you, this is a great convenient way to collect data. Okay, the results are not always going to be reliable, because if you are if this sample is supposed to represent a population, okay, if it's supposed to represent like the population of all of San Bernardino, okay, the whole, let's go back to the whole which ice cream is best example. If it's supposed to represent like what San Bernardino thinks the best ice cream is, and we're only taking data, we're only using the sample of people that bought ice cream at that one truck that one day, do you think that's a good representation of the entire population of San Bernardino? I mean, because honestly, I think there are a lot of variables, other factors that would be acting on here. Like, why are people all gathered at that time of day? Is there a certain demographic that gathers around that time of day and buys ice cream? Is it all families? Is it all kids? Are there older people? Is there like a particular event that's going on, and that's why certain people are gathered? Because if there's an event, then basically everyone there is going to have similar interests. They also might like similar ice cream. So there are a lot of, there are other factors that are acting on this situation, and that kind of makes it so that your results are not going to be that reliable, okay, with convenient sampling. So anyway, they can be when you're getting convenient sampling data, they can be readily obtained. They're very conveniently obtained. All right, your data. And this can be useful if there are not a lot of resources that are allocated to the study. Okay, so if you are like a starving master's student or a starving PhD student for you're studying, you don't have a lot of money, you don't have all these grants, you can't actually allocate too much time, or you don't have all the maybe software or other things like that, so you can gather larger lists or actually go out and fly around and interview different people or anything like that. If you don't have those type of resources, convenient sampling is great. Like I said, it may not give you the best results, it may not be as reliable, but convenient sampling can really get the job done. Okay, that's really all it is. It gets the job done. Okay, so let's talk a little bit more about limitations or problems with convenient sampling, because we all know that it's not reliable. So why is it not reliable? Well, there's going to be bias in every single group, okay? And you're probably going to miss out on certain subpopulations or any things like that. If there are certain minorities within the group, you're probably going to miss out on those. They might be counted very little in your sample size, or maybe not even at all, because you were only taking what was convenient at the time when you decided to collect data. So your results can be severely biased. Like, for example, like let's say you wanted to survey the people who are going to like a health fair. Okay, so you sit at you create your own, I don't know, booth in front of some kind of test where they're doing diagnostic testing for mammograms and like other health stuff, right? And you decide that whoever stops at my booth or whoever I can get their attention and ask them some questions and all that, those are the people who are going to be in my convenient sampling study. Well, all the people that even go to, first of all, and you're expecting this sample size, right, to represent maybe the whole town or the whole county. The thing is, this sample size may be very, very biased, because, I mean, who goes to a health fair, right? Those who are health health-minded, right? Those are health-minded, and those who probably are, yeah, those are health-minded, whether they like to stay healthy or whether they know that they have health issues and they need to start going to things like this or whatever reason. But you're probably not going to see young people or athletes. You're probably not going to see people who don't care about their health. So people who like to eat junk and not exercise, they're probably definitely not going to something like this. But you would see people who want to either start a healthy life or who are just older and more mature and want and have a healthy lifestyle. Most likely those are the type of people that you would see at this place. So that's not a good that's not a good representation of the whole city of San Bernardino, right? Or the whole county. And definitely wouldn't be, you'd be excluding a lot of people, so your sample size would be severely biased, okay? Okay, the last one. All right, so multi-stage sampling. This is where you can take within your study, you can take like a combination of different sampling methods and put them together in your different data collection procedure. Okay, so this is not like how exactly people do it. This isn't like a set method, like an official method that you're going to find in a book, but this is just an example of what you can do if you're doing multi-stage sampling. So let's say you have like just a huge sample. It spans or like a list, and it spans over like a couple states. So you really want to kind of narrow this down so you can get a really good collection of data. Okay, so maybe the first stage of your data collection in your samples will be getting a cluster sample of states. Maybe you have 2 different states that you need to go through. Okay, so let's say you have 2 different states that are next to each other, and you need to go ahead and start, you can do cluster sampling with this. So you can go ahead and cluster this, break it up into its different parts, different regions, and then you can choose a couple sections. All right, so now you chose some small sections of your cluster data that you're going to use, and these are totally random. All right, so that whole amount, that led to this list. All right. Okay, so we were able to shorten it a little bit in stage 1. Then stage 2, we take this and we do simple random sampling with this. Okay. Well, maybe we could do that with each different state within this sample size, within this sample. Okay, so we'll do some simple random sampling, and we all remember how that was. Okay, then you take your random sample, whatever you got out of your simple random sampling. Okay, remember just picking random samples out of a hat. Just remember that that example, kind of like that. You pick random samples from this. Maybe you want to make sure you get some random samples from each state. Okay, so let's say we got random samples from each state after we already put that sample over here. Okay, so now we have that. Now let's try, maybe stage 3 is that we want to do we want to take our sample, so far what we have, and do a stratified samples of schools within these states. So then we take this and we do our stratified sample. So maybe we want to do urban schools versus rural schools. So we'll just put everyone in their box. All right, so we put all the rural schools here, everyone on that list from here, from this sample, and then we'll put all the urban schools, list of schools here. Okay. Then maybe your stage 4 is to do a stratified sample of these classrooms. So now we go into the schools and we do a stratified sample of the classrooms. So I don't know, 11th grade or like K through 12, all the different grades. So you have 1st grade, 2nd grade, 3rd grade, 4th grade, 5th grade, so on and so forth. And from the urban sample, you'll have like a certain amount of kids that are in each different grade. And then you can do that with the rural schools as well. So you can go ahead and separate them into different classrooms or grades, I guess. Okay. And then, you know, maybe there's a lot of first graders, less second graders. I don't know why, but, you know, and then you can gather data like that. I hope this kind of makes sense a little bit. So this is you doing going from 2 full states worth of data in a gigantic list, or list from both states, schools, I guess. And, you know, this first step was to cluster them, okay? And then from there, we did a simple random sample, okay, from the different counties or the states, okay? And then from there, we were able to take a stratified sample of the schools and put them in strata of urban and rural. So separate the schools into urban and rural. And then from there, we were able to further separate the rural and urban schools into classrooms or like grades. So now we can see, you know, how you're able to really get a good sample. Now we're getting good representation of just a small sample size, but we went from 2 states down to this little amount, and you know this is going to be good data. That's all I have to say. Okay, so convenient and multi-stage sampling. Basically looking at the limitations and whatnot of both. You should avoid using convenient sampling unless the question is low risk. Okay, low risk questions are more generic kind of questions. Okay, if you know that there's a lot involved in your question, okay, there are a lot of factors involved, you can already see a lot of biases, then convenient sampling isn't going to help you. It would be a waste of time, because you know whatever sample you're going to gather from your convenient sampling is not going to be a representation of the population. Okay, so only if it's low risk, so very more generic questions work with convenient sampling. Okay, so also use if the only type of sampling possible under the circumstances, because no matter what, convenient sampling it's never going to be that reliable. Okay, it's not the best type of sampling to use. So you should really only be using convenient sampling when you need it to be that convenient. Okay, when you don't have any other resources and you just have to do what's convenient, then that's fine. You have to do what you have to do. But you want to stay away from that, especially if it is not a low risk question. And then multi-stage sampling. Okay, multi-stage sampling is the type of sampling that you want to do if you have a gigantic population to work with. If you, like in the previous example, if we were working on looking at like the school situation for 2 different states, that's a lot. Those are a lot of individuals within that huge population. So yes, using multi-stage sampling to narrow things down so that you have a smaller sample size to collect data from works so much easier. Okay, so that's how you can come from a gigantic population down to like a really small sample size. Okay. I hope all this makes sense. I hope it helps. I'm sorry everything is late. I will be getting more videos to you shortly, but don't forget that you guys have an extra credit opportunity with this video, and I think in other videos in the future we will definitely also be offering extra credit opportunities, so you definitely want to stay tuned. But don't forget about the extra credit opportunity for this particular lecture video, and write your crazy story in the comments. And like I said, the craziest story, the funniest one, is going to get extra credit. Okay? Bye.